All right, so I think this is recording. Let's take a look here at problem number 10. We want to solve this equation. This equation is a radical equation because I see a square root there. I know to get rid of square roots so I can square a square root, and to balance the equation, I would have to square both sides. So if I square the right-hand side, that gets rid of that radical, and to balance the equation, I have to square the left-hand side. So this resulting equation is a quadratic equation. And we know from experience that quadratic equations have two solutions. Now, the solutions for a quadratic are always going to satisfy that quadratic equation. But in this case, when we squared both sides of the radical equation, it's possible that this new equation has solutions that the original one does not have. It may have some extra solutions. So when we do get our answers, and we're expecting two of them, they may not both satisfy the original equation. We're going to have to plug it in and check. All right, so this is a quadratic equation. Let's get it in standard form. I prefer to have a leading coefficient, so I'm going to leave that m squared right where it is, and I'm going to add m to both sides. When I add it on the right-hand side, that term cancels, and then I have to add it on the left to balance the equation. And you'll notice that the minus m, since this m changed sides of the equation, then in front of it, it changed signs. It was a minus m, and now it's plus m. Well, with the 20, I'm going to subtract 20 to cancel that term, and to balance the equation, I'll subtract 20. And notice that the term changed sign. If it changes sides, it changes sign. All right. Now, with a leading coefficient of 1, that makes this problem easier to factor if it can be factored. So, is it possible to come up with two numbers whose product is negative 20, but when you add them together, you get a 1? So you start trying different combinations. 1 times 20, well, one of those is going to have to be positive and negative, and the larger one's going to have to be positive. So negative 1 times a positive 20 definitely gives us the negative 20, but it adds up to 19. It doesn't add up to 1. So there's no way that negative 1 and 20 are what we're looking for. If you try negative 2 and 10, that adds up to 8. But then when you try positive 5 and minus 4, it works. So that part of factoring is referred to as trial and error. And the more possible combinations there are, the more difficult it can be sometimes to find the right combination. All right. So if we multiply those together, we get negative 20, but if we add them, we get positive 1. If we have a zero coefficient theorem that says if you have a product that is equal to 0, then one of the numbers has to be 0. So if this first number is 0, well, then m would have to be a negative 5, because a negative 5 plus 5 gives you 0. And over here on the right, on this factor, 4 minus 4 would give you 0. Now, although those are solutions to the quadratic equation, they're not both going to be solutions to the original, because I can see that now. If I replace m with negative 5, on the left-hand side, I have negative 5. But on the right-hand side, I have a square root. And I know that by definition, this square root is always equal to a positive square root. Negative 5 is not equal to positive 5. And this is extraneous. And like I say, although it satisfied this equation, the price we pay sometimes for getting rid of the radical and squaring both sides of the equation is that this new equation has some extra solutions that the original one doesn't have. In this case, negative 5 is one of them. Now, will 4 check? I don't know yet. I'm going to have to plug it in and see. On the left-hand side, I have a 4. And the big question is, when we do this arithmetic, is it going to result in 4? 20 minus m, if we're replacing m with 4, 20 minus 4 is 16. And yes, it's true that the square root of 16 is equal to 4. Because, like I say, that symbol is defined to be the positive square root. It is incorrect to think of the square root of 16 as plus or minus 4. We have to put in equations that we solve, we have to put the plus or minus in because the by definition it's positive. And it usually comes from taking the square root of a variable. The square root of x squared is the absolute value of x, and the plus or minus comes from that, not from taking the square root of 16. So the m equals 4 is our only solution. All right, well, I hope that helps. I will talk to you later. Bye.